Welcome to the On-Premise IT Podcast, the only show that dares to be both on topic or on premise, and sometimes on location or on premises. Each time we meet, we bring together a group of IT experts to discuss a single idea or premise. On today's episode, which is brought to you by Solidigm, we're talking about QLC SSDs. Are they really ready for mainstream? Well, that's the topic of today's discussion. Before we get into that, though, let's meet who's on the panel today.
Hey, Stephen, I'm Roger Correll. I'm with Solidigm. I'm in the data center organization, and I am the director of solution marketing.
Hi, I'm Karen Lopez. I'm based in Toronto. I'm data chick on all the social medias, well, most of them.
And I'm Alistair Cook. I'm an independent analyst and trainer based in New Zealand.
And I'm Stephen Foskett, organizer of Tech Field Day, publisher of Gestalt IT, and host of this podcast, along with our Utilizing Edge and Weekly News Rundown podcasts. My background is in storage, though, and one of the things I have known and seen and lived through for many, many years is the concern about multi-level SSD, multi-level NAND, and people feeling like it's not ready for prime time. Now, this goes, Roger, as you know, all the way back to the earliest MLC when they first started having multiple bits. And now, we're at quad 4 LC. And so it's natural, I suppose, that people might be saying, hey, wait. Is that really ready? Is it reliable? Is it fast? What do you think?
So great question, Stephen, and you're absolutely right. It's interesting when you go from, kind of look back through the various transitions of, bit per cell density increasing. So whether it was SLC to MLC, MLC to TLC, and now here we are with TLC to QLC. There always seems to be this angst in the industry around, wow, what does this bit per cell density increase mean? And there is this almost kind of, I guess, like these rules of thumb that the industry, regardless of the transition, applies. So I call these, and I don't know if my colleagues at Solidigm call them, but I call these like the rules of thumb, the misconceptions about the bit per cell density increases. So there is a perception that read performance comes down significantly with bit per cell. And I'm here to tell you the reality is our latest QLC products, which we will be introducing shortly and we'll talk about later in the podcast, have equivalent read performance to TLC SSDs. There is a perception that write performance comes down significantly. And our latest generation of QLC products perform within about 20% of certain TLC SSDs that are targeted at kind of that read intensive or mainstream workload. There's a concern that latency doubles with every bit per cell. Our TLC SSD latency on average across kind of all latency metrics is within 20% of what we consider our class leading TLC SSD. Write endurance. The industry expected, this is kind of cool. The industry expected write endurance for QLC to come in around 150 to 1,000 PE cycles. We're at 3,000 PE cycles with our fourth generation QLC. And so when you look at those PEs, 3,000 PE cycles, you throw that on massive capacities, you're really dealing with just a huge amount of petabytes written that is more than ample for a lot of mainstream and read intensive workloads. And then finally, there's this perception that data integrity or data errors increase. And our QLC SSDs have equivalent quality and reliability for both a drive reliability and kind of a data integrity or data reliability perspective as our TLC SSDs.
So given that those claims, this whole idea, the perception versus the reality here, I guess, have you first, Karen and Alistair, have you heard people talking about MLC, TLC, QLC as being somehow a compromise in terms of reliability and performance? And if you have, what do you think about that from a technologist perspective?
I think Roger's absolutely on the point here. We've seen this just continuing through. Every time there's an innovation in solid state storage, there's a perception that there's got to be a cost. Something has to be lost in order to gain this increased density. And the reality I think we've seen each time is that products designed for the different characteristics of the underlying media can actually alleviate a lot of the expected differences. If you just implement exactly the same kind of technology in the drive that you'd use for SLC with QLC, yeah, you're going to get a pretty poor drive. But if you design the drive, the firmware, the controller, the actual over-provisioning, all of those other elements around the capabilities of the actual flash underneath, you see far fewer of these constraints. It's fundamentally comes down to you need some time to develop that engineering, and once that engineering is developed out, the products become reliable and fit for a particular part of market, and that's another important element. These aren't products that you're going to use for absolutely everything in your entire storage estate. And the decision becomes where in your storage estate makes sense to use the product rather than should I use it at all or should I stick with what I've always been using.
I agree to a degree with what Alistair said. I mean, of course, I agree with him. But I think, like, as a data person, I see everything beneficial about optimizing technology use for your data stories, your data workloads, the size of your data, the trade-offs. So one of my engineering mantras is everything comes down to cost, benefit, and risk. And I also like to rely on my systems engineering, systems design engineering backgrounds on every time you optimize a subsystem for a particular use, there's a trade-off. And that often comes at the cost of something else. We see it throughout our lives. We see it in engineering, but that's not a bad thing. It's like what we learned when we went from regular old transactional databases to data warehousing. So we went from optimize for write to optimize for read, and we use those two different architecture approaches for different data workloads. So I kind of see a really huge analogy here. Like, if what Alistair's saying, if it doesn't matter that you've optimized now to have what I'll call more density in your storage, but you play off that optimization by taking care of the trade-offs, why should this be a downside to any of it?
So great comments from both. I think if it's okay, I want to comment something particular that Alistair talked about. I think Alistair he might not have used this language, but he talked about the right workload or the right target. So we are not here saying QLC for everything, but QLC for a lot of things. And a lot of things are becoming, that lot of things is becoming even more. I don't know if that was a twist of phrase or whatever. As you look at workloads becoming more and more read dominant, right? You look at the size of AI ML models, the most advanced natural language processing models have increased 10,000x in the last 5 or so years. Maybe something that's more relatable for a layperson is a 2-hour HD movie is almost 10 times bigger than it was just 6 or 7 years ago. So there is a need in the market to store and access vast amounts of data efficiently at speed. And that's really what QLC excels at. So again, to get to the points that Alistair and Karen are talking about, you deploy QLC in the right area, which we believe is a wide swath of mainstream and read intensive workloads, and you are going to get value without any, I hate to use the word, without any sacrifice to what you require at a solution level.
One of the interesting articles I read recently was about organizations that are retiring storage systems, or at least retiring the solid state storage that's at its, they've depreciated it, it's worth nothing on the books, it's 3 years old, they're retiring it, and then they're looking at the actual life left in these drives, and that they're 3 years old, have been used intensively, and they've only used a third of their write endurance across those 3 years. I think that really targets towards this idea that a lot of workloads are transitioning to be a lot more read intensive, and that once the data has been paved down, it's not changed.
And just to kind of further that point, so absolutely agree with this increasing, shift to read dominant workloads. We're seeing kind of drive trends that are kind of reactive or follow that workload shift. One is what you pointed to. There are large scale studies that you pointed to one study. I'd love to get access to that. There's a large, I want to say, almost 2 million drive study that came out of the University of Toronto within the last couple of years that showed that 99% of the drives at the end of their warranty, 5-year life cycle, consumed something like less than 15% of the available writes on the drive. And correspondingly, as a company, we're seeing not only within Solidigm, but across SSD vendors at large, we are seeing a decline year over year in kind of the average drive write per day rating shipments going out to now. I think if you just went back a couple of years, your average was maybe around, more than one drive write per day. Now, the vast majority of your drives are shipping at or slightly below one drive write per day.
Like, I support all that as well. And I wanted to point out that most of the things I've heard out in the industry about concerns about QLC wasn't so much about write speeds, but it was about this perception, or sorry, the other way around, wasn't so much about read speeds, but the perception that write speeds are slow. And, I point out to people that very large read optimized data workloads, typically we don't care as much about the write speed as the read speed because we're optimizing for read. And the example I use is some very large analytical workloads, like we don't even back them up because we just reload the data because that's can be faster or just as fast as a restore. And I think that's the nature of, like, I live mostly in the transactional world. Sorry, everyone, it's because I'm old. And that's what my background is. And you use the word the switch to analytical or the switch to read optimize. I like to think of it as we're just growing that like crazy because now we have the hardware and the tools and the storage and the affordability of storage to actually grow all those workloads. Whereas, back in the 80s when I started working, we only had transactional because that's all we could afford to do, maybe with some reporting. So I'm super excited about the growth of these new uses, whether it's AI or ML or cognitive services or any of those things, because I've seen all the technology rise up to meet those needs.
Right. And Karen, just to tag along to a comment you made about the rise of these read dominant or read intensive workloads. This same large scale study that I talked about a minute ago, it also showed that the vast majority of drives, and again, this was an enterprise study covering almost 2 million drives, that your average mix was 80-20. So, very, very read heavy. So.
One of the other things I think that we've seen from a storage perspective, and this has been interesting, is that the capacity of drives also affects reliability in that, if you have, terabyte scale, multi-terabyte scale drives, then that gives you the ability with, wear leveling to make sure that you're not really hitting, the same cell again and again and again. And it's one of those things I think that maybe is hard for people to kind of get their heads around. But once you think about that, and once you realize that, you're not talking about the old days when you had like a 32 gigabyte flash drive that you were continually hammering on, if you've got terabyte scale drives, you can spread those writes out, and it doesn't really hit it as hard as it used to. I like to use the analogy of batteries, like electric vehicle batteries. If you had a tiny battery that you're continually charging and discharging, then it's obviously putting a lot more wear and tear on that battery pack than if you have a very large one like modern electric cars do, where you're continually keeping it kind of in that sweet spot in terms of performance. And it's really the same when you look at these drives. And of course, a lot of these drives also have buffers and other ways of mitigating the sort of write intensity that's going to them. And as Karen points out, applications are less intensive as well because these things are much more mainstream. So I think that we should kind of turn the page here for a second and think, okay, so if a lot of the sort of old wives' tale about QLC or the concerns about QLC, I don't want to say that it's not right. It is right. I mean, the technology does have less write endurance, but there's just more of it, so it isn't as much of a problem, and the drives are designed for it. What do these drives deliver? So obviously capacity, right? If you're QLC, you got more capacity in the same space. Tell us a little bit more about these. So, you've got a QLC SSD. What does it give you?
Yeah, sure. Okay, so let me start with maybe just kind of a high-level overview of the capabilities, just to kind of sum that up, and I'll be speaking to our 4th generation of QLC SSDs. Let me repeat that again. We are on our 4th generation of QLC SSDs. We have been shipping these in volume since 2018. So it's that that legacy of QLC leadership that has enabled us to deliver drives of the capabilities that I'll speak to. So our 4th generation family will consist of what we call an essential endurance drive. So this will give you around 0.58 drive writes per day, massive petabytes written, which we believe is more than sufficient for a lot of these target workloads that we're talking about. But what's really exciting, what you were asking about, Stephen, is the capacity of these drives. They will span, the essential endurance will span 3.84 terabytes all the way up to 30.72 terabytes and be available in what we think is arguably an industry-leading portfolio of capacities that populated on a wide range of form factors. So for customers who want to kind of utilize their existing chassis, existing infrastructure, we will have up to 30.72 on a U.2 form factor. And for customers who really want to get the benefits out of EDSFF, and not to go deep on EDSFF, but really quickly touching on the benefits of space optimization, operational efficiency, much more efficient cooling, improved signal integrity, et cetera, a better serviceability. So there's a lot of reasons to move to EDSFF. So on E3.S, up to 30.72, and on E1.S on up to 15.36. So we believe with that range of form factors and capacities, we can really, we're in a good spot to help our customers get the benefits of QLC, whether they're solving for a storage array, a server configuration, a 1U server, a 2U server, et cetera. And it's worth repeating, and then in terms of performance, TLC equivalent reads right up there, equivalent to, in some cases, slightly ahead of best-in-class TLC drives that are targeting these same mainstream workloads that we are with this QLC. So there's multiple benefits, Stephen. So it is space efficiency. When you talk about the number of servers or racks to store equivalent data. So space efficiency, capacity density is one advantage. And then you could almost think of it as an offshoot of that, or a natural outspring of space efficient density, is the TCO advantages that come with that. Less hardware to acquire, savings of data center footprint, lower power cost, lower cooling cost. And then to kind of continue that and game that out almost to the next step with improved TCO sustainability is an offshoot of that. Lower cooling costs, less hardware to disposition at the end of life of the drives, a smaller data center footprint. So storage density, TCO, sustainability.
So you had me at sustainability. That's something I always want to hear about as we're innovating these new technologies and everything. So I do like that whole story of just fewer pieces of hardware plus lower power consumption. I'm thinking of the days when we're here talking about dodeca LC SSDs. So I think that's 12, but I always get that mixed up. um, I do think, though, that there are a lot of people who don't understand that specific thing about this greater density story, is that they're always thinking that something more powerful requires more power. And I think it can at times, but also, again, coming to the bigger picture of TCO, that this is also a great reason to be looking at, fewer pieces of hardware.
Right, exactly. Yeah, Karen. So we've actually done TCO analysis versus what I guess you could call kind of the top configurations that we think our customers will consider these drives for. So we've done TCO analysis using kind of object storage as maybe a proxy for overall TCO opportunities with this. So our TCO for solving for, let's say, a 7 petabyte object storage array, comparing like TLC form factor to like QLC form factor, but you can get twice the capacity on a per drive basis. We're seeing TCO benefits, that are almost approaching 30%. Now, when you factor in the modern form factor into the equation, then that TCO jumps even further because EDSFF, thinner, more efficient than U.2. So the benefits get even higher. Now, so that was an all TLC to all QLC array. Now, when you look at solving for that same 7 petabyte storage array, looking at a hybrid configuration, now you're getting an all QLC versus hybrid TCO that is getting between 35 to 40% TCO savings. So significant savings.
I've always been interested in the EDSFF, whatever the current name for it is, technology. What was first launched as the ruler, and I was very excited to get my hands on one when I was at Supermicro a few years ago and get to look at it. I hadn't considered that difference in the physical shape leading to better, that was a big driver for the cooling. And I was thinking about it, that the distance from the edge of the ruler to the center is much smaller than the distance from the edge of a U.2. And that's going to give you much more efficient cooling. And there's a whole lot of benefits that flow out of that change of form factor that I hadn't really thought of. I'd just seen it as you get more storage in the same space.
I can't remember the exact numbers, but you're right. We call it a Z height. The Z height of let's say an E3.S is going to be much thinner than the Z height of a U.2. So literally, you are going to be able to get more of those across the front of in the case of E3.S, I would assume we're talking about a 2U rack unit. You're going to be able to get much more across. To your point on cooling efficiency, the way you get to really big capacities on a U.2 is you take that board and you sandwich it, and now you've got all of these die facing in the center. Your NAND media is facing in the center. with all that space available on the PCB in an E3.S, your die is facing outward, so they are closer to heat dissipation. So you're able to get much better cooling efficiency on an E3.S versus a U.2.
And there's a different dimension to the density as well, as we start thinking about putting these into places that aren't designed to have a large amount of IT. And this is where the Utilizing Edge podcast starts to be very interested in QLC, is the idea that we need more and more data inside smaller and smaller locations. As an example, a store that's running a large retail business will be storing video surveillance information, but also receiving a whole lot of images for digital signage, and that's transitioning towards digital video signage, so even more data being sent down. This idea of getting more data efficiently, low cost, at my thousands and thousands of locations, it's directly applicable in the same way that lots and lots of drives inside a smaller space is applicable in a bit larger data center. So I think there's use cases for this beyond simply I need a lot of storage in one place. In terms of the 7 petabyte object store.
I think you are spot on, Alistair. Yeah, that TCO number that I told you was in maybe in all likelihood kind of a core data center, but for some of the reasons that you're talking about, we are seeing I don't know what the industry calls it, a decentralization or a redistribution of compute and storage from core to mid-tier to edge. And that the further you move from the core, so storage challenges we think are kind of fall into the same buckets across that continuum, but those storage challenges become more acute the closer you get to the edge, for obvious reasons. Space is more limited. Maybe your available power is more limited. That facility might not be built from the ground up for cooling efficiency. Real estate is expensive. So I think the benefits that QLC can pay off in core data center deployments become even more so when you're talking about mid-tier deployments, and even more so when you're talking about edge deployments.
So we've talked here about the transition from multi-level to TLC to QLC. We've talked about the realities of what these drives can do in terms of just the flash, but also in terms of wrapping them and producing a drive in a new form factor that has different capabilities and new benefits for end users. What do we think about how these things will be used in the real world and what the real world benefits of these things are really going to be? Al, let's start with you.
I think there's a lot of benefit here around using the right tool for solving the problem. And the sort of problems that QLC Flash in a well-engineered system are going to solve are around that huge amounts of data, primarily used for read use cases. And that may be just that it's write-heavy data that's deduplicated, and so you never overwrite. And I think the TCO element of it, the combination, I mean, it hits as a triple factor of less hardware to manage, less cost to operate it, and less impact on the environment because of those first two. I think the adoption of QLC is going to be an essential part of moving forward with storage and IT.
I think that my advice to complement what Alistair said is that don't bring your old school storage business model to evaluate new hardware and technologies. And so to translate that for people, don't use your old spreadsheet. Think about a true total cost of ownership that includes green power consumption, as well as fitting the technology to your modern data workloads.
So I agree with both what Karen and Alistair said. A term that we've kind of been using internally within Solidigm is that QLC is right sized for its targeted workloads. I think I get back to a term Karen said, old school or dust off your spreadsheet or whatever. That TCO math that you've been doing with TLC that customers are so familiar with, imagine what you can do with QLC for mainstream and read intensive workloads, paying off with TCO, paying off with sustainability, paying off with just a smaller storage footprint, a denser footprint. And I guess maybe I'll wrap it up with kind of I prefer, rather than call to action, to call it kind of call to opportunity. I think the opportunity is become familiar with these, with the fourth generation of QLC drives that Solidigm launched in May. We have a TCO tool that is available on our website. There's a lot more information available on our website. I believe, hopefully I'm right about this, I believe our TCO tool also has some recent kind of sustainability features built into it. And that'll give you, kind of it's not a perfect tool. Things are different, right? Duty cycles are different across workloads, and capacity utilization is different across workloads, et cetera. But it can give a pretty good kind of first pass estimation on your TCO and your sustainability benefits from QLC SSDs.
Yeah, thanks for that, Roger. And I think that it's been really an eye-opening conversation because, again, I think a lot of people out there might be listening to this and just not realizing the fact that we are well into the QLC world. We are well into the ultra-dense world. And also that the form factors of SSDs are radically changing, not just the underlying flash technology. And all of these are allowing us to do things that are fundamentally different from what you could do with SSDs in the past. So I really appreciate that, and I urge people to check out the Solidigm fourth generation QLC SSD family and learn more. Before we go, Karen and Alistair, where can we continue this conversation with you as well?
So definitely on social media, I'm Data Chick. I'll be talking at the Data Governance and Information Quality Conference in early June, and the Enterprise Data World coming in September. So I'm really looking forward to that.
And you can find me online as DemitasNZ. So that's demitas.co.nz for my blog, and DemitasNZ on Twitter. You can also find me on the Utilizing Edge podcast along with Stephen. And you'll also find me in person at VMware Explore in August or September, whenever it is.
Thanks, Alistair. Indeed, I do recommend checking out the Utilizing Edge podcast, which you can find in your favorite podcast application. You'll also be able to tune in for another Edge Field Day event coming up here in a couple of months in July. We'll be talking about Edge applications in a lot more detail. Thank you so much for being part of this episode of the On-Premise IT podcast. If you enjoyed this discussion, please do subscribe so you won't miss an episode, and we'd love to hear your comments. This podcast was brought to you by Solidigm as well as by GestaltIT.com, your home for IT coverage from across the enterprise. For show notes and links and more episodes, go to GestaltIT.com/podcast. Thanks for listening, and we'll see you next time.